Hello guys. So basically today we are going to deal with a chapter called as coordination compounds. So basically you can just see the heading. This is beginning with the coordination compounds. To have a basic knowledge of the coordination compounds, first we have to understand that what are the different types of the salts we are going to see. So basically when we are dealing with the salts, you are having mainly three classifications. One is called as a simple salts. Okay. The second one is called as a double salts. And the third, which is the most important thing and what our chapter is going to belong, that is called as a complex salt. You can ask me, so what is the difference between all the three? Basically, in simple salt, let me give you an example. For example, if I am taking over here as NaCl. So what happens when this NaCl is dissolved in water? Okay, when you are going to dissolve it. So basically I am just writing my ionic configuration. You are going to get as what? Na plus Cl minus. Okay. That is when you are taking your table salt, whatever the normal salt, you are going to dissolve in water, you are going to get the respective ions. So whatever the compound is there, that is being completely broken off. Coming with respect to the double salts, let me give you an example that is called as a kernelite KCl dot MgCl2 dot 6 water. So what happens when this is a combination of the two simple salts? You could just see that here one is a potassium chloride, another is your magnesium chloride. So it's a combination of the two simple salts. So when you're going to dissolve this part, so you're going to get the respective ions as K plus, and also you'll be getting the ions as Mg2 plus, and also the ions of Cl minus. So you'll be able to understand what does it mean. So simple salts means it is just a single compound, you could just see. So which is undergoing complete dissociation to give you as Na plus and Cl minus. Whereas the double salts, they are the mixture of the two simple salts. Okay, but when you are going to dissolve it in a water, of course here also you are going to get your respective ions. But the major thing when you are dealing with the complex salt, very much interesting part, that is, for example, if I am taking as K4 FeCN6, basically we are going to see that how to name this, but just for a while you just take this as an example, K4 FeCN6. So when you are dissolving this one in water, you are going to get as K plus and FeCN6 4 minus. Can you able to notice what is the changes? So in simple salt we saw that whatever the salt you are taking, that is giving you the complete ions Na plus and Cl minus. In double salts we are also able to see that you are going to get a complete dissociation and you are going to get as K plus Mg2 plus Cl minus. But when you are coming with respect to the complex salt, we are able to notice that whatever the atom which is present outside the square bracket, that is giving an ion, okay, but the one which is present within the square bracket, that itself is remaining as it is in the ion. So these type of salts are called as what? Complex salt. So that is the reason what we are dealing over here is double salts means what? They are made of two simple salts and they retain their properties only in their solid state, and in the solution state they dissociate to give the respective ions. But when you are coming with respect to the complex salts, here what they are saying, these are the substances which contain at least one complex ion. Here complex ion is this part. You're able to see, so complex ion is which is written within the square bracket. Okay, and they are retaining their properties both in the solid as well as in the solution state. So double salts means what? They are retaining their properties only in their solid state but not in the solution state. But in the complex salt we are able to see that they are retaining their properties both in the solid as well as the solution state. So we are in this chapter, we are mainly going to deal with this complex salts. Okay. So before having the vast knowledge of the coordination compounds, let us now deal with one by one what are the respective definitions we would be requiring over here. So first one is called as a coordination entity. So by using itself, they are given as it constitutes a central metal atom which is bonded to a fixed number of ions or molecules. Let me go with an example over here. So in the example, they are given as cobalt, which has been bonded to Cl, that is your chloride, yeah, and that of your ammonia, NH3 thrice. You are able to see over here. So coordination entity means what? So whatever the metal is over here, that is called as what? Central metal atom. Okay, and the one which is bonded over here, that is they are acting as which has been bonded to this cobalt. If we take an example over here, so basically we could just see it will be in this shape. Okay, that is Cl, 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 and that of your NH3, NH3, and an NH3. You could just notice over here. So this is written in the square bracket. So this part, the metal will be called as what over here? As a central metal atom, and the one which is bonding it, able to see alpha, this metal has been bonded to some specific number of other atoms. So these are called as ligands. So coordination entity means what? So which constitutes both your central metal atom as well as that of your ligands. So overall this part will be called as what? Coordination entity. Coming with respect to now detailed analysis, what is called as a central atom or the ion? As itself which has been said earlier, so in a coordination entity, the atom or ion which is bounded to the definite number of the anions or the neutral molecules in a definite geometrical arrangement is called as a central atom. That is nothing but taking the same example over here. So what they have said, a metal which has been bonded with a specific number of anions or a neutral molecules. Here we could see that here chloride is your anion, whereas ammonia is your neutral molecules. So this will be called as what? Central atom. So basically we will be saying that our central atom is a Lewis acids. Hope so you can just clarify with it why they are called as a Lewis acids, because it's a central metal atom which is accepting a pair of electrons from all these ligands. So whenever an atom is accepting a pair of electron pair acceptors, so they will be called as what? Lewis acids. So central metal atoms are nothing. So they are the atom or the ion which is bonded to a definite number of the anions or neutral molecules in a definite arrangement. You could just see that they are having a particular arrangement which is called as an octahedral arrangement. We'll be going to see it in our further classes over here. So this is called as what? Central atom or ion. Coming with respect to the next coordination entity which is present within this coordination entity, we have dealt with now our central metal atom. Now we have to go with a part which is called as a ligands. So what this says, so ligands are nothing. In this example you could just see here chloride, they are acting as a ligands. Your ammonia is acting as ligands. So what you can say, so the ions or molecules which are bounding to this central metal atom or the ion in the coordination entity, so they are called as the ligands. In simple words, nothing. So whatever the molecules which is binding your central metal atom or ion, they are called as ligands. Is that clear? So we have dealt with what do you mean by a simple salt, what do you mean by a complex salt, what do you mean by a double salt. Okay, and we came to know with respect to the different definitions that what do you mean by a coordination entity, very much important, which coordination entity is nothing which constitutes both your central metal atom or the ion and the ligands. What is your central metal atom means which is bonded to a specific number of the ligands. What are ligands? So these are the atoms which are donating the electrons to your central metal atom. Okay, for example, if I just say, they are given with you an example over here.